And now it's my great pleasure to introduce our first featured speaker. I had a few moments to chat with him this morning, and I said, you know, you have a pretty impressive and long biography. Can I just say that you're a big muckety-muck and people need to know you? He said, sure, yeah, that'd be fine. But he actually deserves quite a bit more than that. Dr. Blar is a professor of cognitive psychology at the Steinhardt School of Culture, Education, and Human Development at New York University. He holds a PhD in developmental psychology from the University of Alabama at Birmingham, and for the last 2 decades has been conducting research on the development of self-regulation in early childhood. His research has focused specifically on the development of executive functioning and how early experiences get under the skin to influence executive function development through its effects on stress physiology. He serves as a consultant on numerous federally funded research projects and serves on advisory boards of several initiatives focused on early care and education and child well-being, including working in Arizona, Maryland, Ohio, Washington, D.C., and very gratefully, North Carolina. So please join me in welcoming Dr. Clancy Blar.
Thank you, Cindy. Thank you very much. Hi, everybody. It's wonderful to be here. Thank you so much for this opportunity to come and speak with you all today. I'm very, very interested in trying to connect with you as much as I can, and I hope that what I have to say is relevant to you in your jobs. So I'm going to talk about research on self-regulation development, the science of self-regulation, and I want to cover some constructs, terms, definitions. I want to talk a little bit about the neuroscience behind the development of self-regulation in early childhood. I want to talk about the role of self-regulation in early childhood education and to some extent classroom quality. And then I want to give some examples of some programs that have successfully promoted self-regulation development in young children with benefits to cognitive outcomes and academic outcomes and some more traditional outcomes that we're interested in. And like I say, I hope this is useful to you in your jobs and your professional development and in thinking about your goals for working with young children and their families. So when we're talking about self-regulation in young childhood, generally what are we talking about? These are 4 to 7-year-olds. We're not trying to turn them into little adults. That would be horrific. That would be just terrible. We're really talking about flexibility, right? So the ability of children to go nuts, to run and play and go wild, but when they need to comply, to rein it in over time, right? So being exuberant, being emotionally expressive, but being able to regulate emotion when needed to do that, to take initiative and be self-directed, but also to comply, those sorts of things. And of course, the sort of conscientiousness that goes along with that and social interaction. So this is very important, of course, and I think it jives with sort of our general goals for children's development. I think we think to a certain extent, or at least I do, that this is what a happy, well-adjusted developing child looks like. Scientifically, though, when we encounter this general construct of self-regulation, there are lots and lots of terms, sometimes bewildering, that I wonder if you're familiar with. So one is executive functions. Is everybody familiar with the term executive functions? There's effortful control. There's executive attention. There's delay of gratification, the marshmallow task. It's emotion regulation, of course. Grit. People heard about grit. Inhibitory control and self-control. And are these different terms for the same thing, or do they go together in certain ways? And to tell you the truth, I'm not even sure about these. But you see these up on the screen. Does anyone feel like they have difficulty with any one of these aspects of self-regulation or multiple aspects of self-regulation in their lives? Do you know any children who have difficulty with some aspect of these of self-regulation in their life related to these? Most importantly, how malleable, how changeable do you think that is? If you were having some difficulty with delay of gratification or executive function or inhibitory control, do you feel like you could work on that and change it? Do you feel like if you knew a child or children or adults, adult caregivers, having some difficulty with this, do you feel like that's a characteristic of the individual or that's something that's malleable? Well, what I want to do, I hope by the end of my talk, I've convinced you that it probably is very malleable, that's highly malleable, but it's really, we get reined in by context. We get reined in by the decisions we make. We get reined in by the context that we're in that limit our ability to use self-regulation. We all have these abilities. They're there. They're sort of all equal, I think, to a certain extent, but we need to set the table for self-regulation. And I feel like that's what early childhood education, one of the important goals of early childhood education and for working with children and families is setting the table for self-regulation. So with that, what I want to convince you is that let's not get bewildered by the number of terms that are out there. There's a pretty straightforward way of thinking about self-regulation and its development that we can group generally. So when we think of executive functions and executive attention, these are the more cognitive, intentional, volitional aspects of self-regulation, right? And the delay of gratification, emotion regulation, they're more the emotional aspect, emotion regulation, emotion control. And when we think of these grit, self-control, effortful control is a temperament construct, right? Grit's kind of a personality construct. These are the more sort of enduring trait-like aspects of behavior over time. And so what I want to talk to you about is something that I've been working on for a long time now, and sort of how to array these different aspects of self-regulation. And so the way to think about self-regulation that I think is really useful is to think about it as a system. These different parts of self-regulation go together. We, of course, sometimes want to equate self-regulation just with the conscious, cognitive, intentional, executive functions, and those are very important, right? The sort of willpower, control of behavior, and we can use them, we can use executive functions to sort of regulate emotion, regulate behavior, and underneath there's a very important physiology that's associated with that, the stress response physiology, and underneath that there are genes, genetic differences. I won't go into any of that today because in the interest of time, but there's some very, very interesting work about genetic differences that are related to the sort of, hit the wrong button, that are related to how sensitive we are physiologically. That, of course, has implications for our behavior and our emotion regulation, and interestingly, has implications for our ability to engage executive functions, to be volitional, to use willpower. So the idea here behind self-regulation as a system is it's top-down, and we usually think of self-regulation as kind of top-down. Why don't you stop doing that? Why can't you control your behavior? Those sorts of things. But what happens when we're unable to engage those executive functions is usually there are lower-level processes associated with emotion and physiology and some genetic differences that interfere with the ability to do that. So that's what I mean by sort of setting the table for self-regulation development and thinking about self-regulation as a system. So that's a really sort of important for what I'm going to talk about in the subsequent slides. Right? So self-regulation, it's the early regulation. When we're thinking about the development of self-regulation in early childhood, the executive functions won't develop until kids are 4 or 5 or 6 years of age, right? We can't really measure them very well until that time point. And what we understand is that the development of executive functions are really being driven by the development in these lower level systems around emotion, around the ability to regulate physiology and regulate behavior, right? And these healthy physiological, emotional, and attention development in the early years, it should say, there's a typo, are indicative of the healthy development of EF. And this has very important implications. It has importance for thinking about high-quality care and caregiving in early childhood and infancy and early education. It says to us scientifically and in terms of just formative assessment and evaluating what we do, we would like to measure some of the activity in the lower level systems in order to understand the development of executive functions, to develop the more willful aspect. And it also very, very importantly, as will become clear, I hope, in the subsequent slides, really indicates the importance of the expectation that we would see big effects of high-quality experiences, either with parenting programs or with high-quality early childhood education for kids in the most advantaged contexts. Because kids in the most disadvantaged context are going to have the greatest difficulty with self-regulation development for reasons that I'll talk about in a minute. So self-regulation develops from other regulation. It develops from warm, sensitive interactions with caregivers, right? And you can think of self-regulation as a hierarchy. The early caregiving relationship is really providing for the regulation of temperature, regulation of body temperature, state, right? Early physiological regulation. It's providing for the regulation of sleep. It's providing for the regulation of nutrition, right? All of that are sort of the initial building blocks of the development of self-regulation. It also develops, right, from individual difference characteristics related to the ability to attend, to regulate emotion, and other physiological characteristics. So you may be familiar with some of the really interesting research on attention in infancy. So what this slide depicts, and I don't have a laser pointer that I can use here, but infants will attend to unusual or discrepant or novel events, right? And what some enterprising developmental psychologists have done is when you present an unexpected event, so this would be like a math example. So there's one thing on the stage, and then a screen comes up, and then a hand comes in with another little doll and puts it down. And so there should be two items behind the screen when the screen goes down. But if you have a confederate, an RA, who takes one of them away before the screen goes down, there's only one there when there should be two there, that kind of thing, if you understand. So it's a violation of expectation, right? An expected event. And children will reliably look longer, even at, say, 6 months of age, at these unexpected events, right? It's as if they're surprised by what they're seeing, which is really interesting in terms of sort of emotion and what's going on. But the idea is that the child is regularly attending to occurrences in the environment, and there are expected regularities that are going along with that, related to attention, related to emotion. And this seems to be a main mechanism of very early learning, right? As well, you may not be familiar with this research, but even very young infants have sort of inherent ways of regulating emotion. Of course, you've seen them. You may not have thought of them in that way, but self-soothing, thumb-sucking, finger-sucking, proximity to caregivers. When children experience a negative event, we see an emotional response, but we also see individual differences in the extent to which children are beginning to regulate those emotional responses through self-soothing or proximity to caregivers or orienting away, or my favorite is avoidance. Trying to get away from the thing. And then, as I said, there's a physiology behind this, right? So we're going to start to get into a little bit of the neuroscience behind what's going on. So when we experience an emotional event or an unexpected event, there's a little bit of a stress response, right? So I won't go into the details of the stress response, but you may have heard of some of the different aspects. There's, of course, the fight-flight response, which is the autonomic nervous system, and there's a slower system called the hypothalamic pituitary adrenal axis. Let's all say that together, the hypothalamic pituitary adrenal axis, or the HPA for short. And those responses to stimulation are very important because, in a way, what's happening is they are signaling neurochemically to parts of the brain to start to pay attention, right? That's what these stress hormones are doing. So we're talking about the stress hormone cortisol, which is a glucocorticoid steroid hormone associated with the HPA axis. There won't be a test at the end, so you don't have to worry about that. But there's adrenaline and noradrenaline, which you've heard of, or epinephrine and norepinephrine, right? And these are activated by these responses to stress, and they actually signal to the areas of the brain associated with the executive functions to control attention, to direct attention to the source of stimulation, and as we're more mature, to begin to direct behavior, right? So, and then in terms of that, it's a feedback loop. Remember when I said that self-regulation is like a system? There's actually a neurobiology and neuroscience that goes along with this in terms of this feedback loop, because the area of the brain, the green area, the prefrontal cortex, signals back to the lower brain structures to try to regulate or modulate that level of stress arousal, that level of stress physiology. And it's very interesting, this actually works in this sort of inverted U-shaped curve. You're probably familiar with this sort of Yerkes-Dodson. You want to be a little stressed out when you go take the big exam. You want to be a little a little anxious when you give a talk or when you go to a job interview, those sorts of things. And actually, that's the case neurochemically. Those stress hormones, when they're at a sort of moderate level of increase, they really help the area of the brain associated with executive functions, the volitional control of behavior, to do their job better, to feed back on those lower level structures and try to maintain this loop, this system, in a good balance, you could think of it, kind of as an equilibrium. And that's very different from reactivity or simple learning or simple fear conditioning, those sorts of things that psychologists have studied for years and years, the more simple aspects of learning. It's very different from the complex types of learning that are associated with executive functions. Right? So this is important because brain architecture, the brain is developing very, very rapidly in early childhood. Surprise, surprise. It is. And much of that development has to do with the sort of setting up of these networks that are related to the different areas of the brain talking to each other, right? So in terms of this network, this self-regulation system that we're interested in, we're very concerned about the extent to which the early experiences that children are having with caregivers are related to the development of this neural circuitry that we know underlies self-regulation development, right? And the idea, and why I'm focusing on stress physiology and stress hormones, is we know that those systems are up and running very early in infancy and early childhood. And I didn't go into it here, but on the far extremes of this curve, right, to the left of your screen and to the right of your screen, as those levels of stress hormones rise too much, they really shut down activity in the areas of the brain that are important for the development of executive functions and the volitional control of self-regulation. And actually, when they're too high, these stress hormones are toxic to brain structures, right? They will actually cause brain structures to shrink and those pathways to not set up in the way that we would like. So we know that a child, and what we don't know sort of is what's the normal range of this. We know that very aberrant care, right? So extreme abuse and neglect very much show these effects on brain development. What we don't know is the extent to which sort of care, what you would think of as care in the normal or typical range at the low end or at the very high end, are related to these processes. But I'm pretty sure it's the same sort of situation that we're talking about in terms of the effect of stress hormones on the development of these brain networks that we are all very interested in because they're so important for self-regulation. They're so important for early learning. All right, so interaction shapes brain circuitry. So I have a little video in here, but I'm not going to play it in the interest of time. that's related to, it comes from the Frontiers of Innovation, the Center on the Developing Child at Harvard University. It's a wonderful resource. If you're interested in that, you should Google Center on the Developing Child. Jack Shonkoff is the man's name who runs it. He's a pediatrician. He's very, very interested in the role of toxic stress, he calls it, in children's development over time. And some of what we're seeing in terms of how we're thinking about self-regulation, the development of self-regulation in young children, the importance of early interaction and early care, and then what we can do about it in terms of early childhood is a very exciting time. As Cindy pointed out, this really is an exciting time in which multiple aspects are coming together, I think, in terms of the science, in terms of the policy, in terms of the political will to really look into young children's development and do right for young children in multiple ways. So just here, when we're talking about these sort of sensory pathways that I mentioned, sort of attention, the ability to pay attention, vision, hearing, those sorts of things, they're developing very rapidly, right? So the process of brain development is one where the neurons in the brain proliferate through the first 3 years, but then are pruned away. Pruned away. It's sort of like pruning your hedge. They're pruned away over time by experience. And that happens sort of in different sequences. Here's sensory, here's language, and here's the one for executive functions, for higher cognitive functions, right? Those networks are being pruned well into middle childhood, right? And in fact, depending on what we look at, the extent to which those networks are active through adolescence into young adulthood. And then, of course, after that, they peak, and then they start to slowly decline into old age, right? As we get a little bit worse at these sort of higher cognitive skills. But the idea here is that we're really in a sweet spot when we're thinking about sort of from age 4 up through age 12 in terms of what we're doing with kids, how we're supporting kids' stress response systems, their ability to regulate their behavior with the goal of really fostering executive function development, right? So there's just an example of this prefrontal cortex that I said is very slow in maturing, and I actually have a little animation to show you this. So what we have here is as the brain becomes more blue, it's reaching maturity, that sort of cortical thinning. Would you play it again? You see the brain's developing sort of from a back to front, posterior to anterior way, and that's cortical thinning, right? And this was based on neuroimaging research. And what it's showing is that this plasticity of the brain through age 5 through about age 20 is ongoing, right? So it has important implications not only for what happens early, but for what happens after as well. And another thing that we really don't know is the extent to which early disadvantage can be overcome by later advantage, and the extent to which early advantage may be trumped by later disadvantage, right? So it places a real premium on the types of experiences that kids are having in schools, having with peers as they get older, those sorts of things in terms of thinking about the development of the brain. And here's just another picture of this. Go ahead and click that one. That's the top view. You can really see it from the top view. These are slides from a colleague of mine at the National Institutes of Health who runs a brain imaging lab, and he put this together several years ago. So the other important piece of information that I want you to attend to before I get off of the neuroscience part is this sort of plasticity period, right? As we saw, it's very high at birth, and it sort of declines over time through later age. But sort of the idea here is that the physiological effort, the sort of cost to the metabolism to change these networks increases over time. It's very plastic early on, but there's malleability later, but it's going to be harder and harder to change. So the importance of laying that foundation, the brain science is with you on this in terms of the importance of early childhood. And that's really what I want to communicate to you today, right? The important implication of this, to sort of get to more of the early childhood context, is understanding that the context in which the individual develops is really going to shape the self-regulation system. That's why I say, you know, if we have difficulty with self-regulation in our own life, if we know children or families facing self-regulation difficulties, these are malleable processes, right? They are very contextually bound. And the way of thinking about this from a sort of scientific standpoint is this, what I call, what's known as a psychobiological model of development. In the psychobiological model, you may have heard about the old nature-nurture controversy. Is it nature, is it nurture? That never worked. It never does, right? Nature and nurture work together, right? So the types of experiences that we're having, especially related to self-regulation, are influencing the development of the biology that underlies it. They're influencing physiology. They're even influencing gene expression, and that's what I mean by my research really examines the extent to which experience gets under the skin. Everyone's familiar with that term, it gets under my skin. We usually mean it it's something that irritates us. And that metaphor holds up here, but it's something that can also be beneficial to us as well. It's really shaping. The more we've learned about the biology of human development, the more we understand the extent to which experience is shaping many of the things that we're very, very interested in about the brain, about physiology, and about behavior. So my colleagues and I have been studying these processes for years. I just want to share some data with you from a longitudinal study called the Family Life Project that is funded by the National Institutes of Health, and it's a birth cohort study of children and families in rural poverty, really small town in Pennsylvania and in North Carolina. And what we do is we collect information on the types of parenting and care experiences that children are having. We collect information on stress physiology, and we collect information on executive functions. There are many other things that we do in this project, but that's what I want to share with you. And the way we collect the information on the stress hormones is by getting these saliva samples from young children. We also get them from parents. I've always wanted to get them from teachers, because they're really good indicators of how stressed out someone is, right? And the idea behind this is to be able to flexibly regulate stress physiology. Like I said, in terms of thinking about self-regulation, are we seeing any evidence for that in young children? So I think that's what I really needed to tell you about it. Half the sample in North Carolina is African American and half are white, and the Pennsylvania sample is all white due to the characteristics of the communities in which these families are living. That's who lives in these places. It's Wayne, Sampson, and Wilson counties in North Carolina, and Blar, Huntington, and Cambria in Pennsylvania. And so we've been looking at these aspects of children's early experience, and I just want to show you here that dark line is sort of a typical pattern of change in levels of the stress hormone cortisol for kids in typical, albeit lower income households in rural North Carolina and rural Pennsylvania. But for kids in very chaotic households, those cortisol levels are remaining high. They're not showing that typical decline. And that's not a good thing, because cortisol is toxic to brain development, right? As I talked about before, it's really expected to influence the development of self-regulation. So kids in very chaotic homes are experiencing these levels of cortisol. You can sort of think about it as self-regulation in terms of, if you didn't know the weather, but you knew it was going to be cold sometime, really, really cold, you might just turn the heat on in your house and just leave it on all the time, right? It's not flexibly, you don't have a thermostat that will adjust to the temperature outside. You just turn it on and leave it on. The house might burn down eventually, but you're prepared against that bad contingency that may happen. That's sort of the way to think about some of this stuff. It goes by this somewhat fancy term allostasis and the allostatic load model. We don't need to go into any of that. But here's what we see some evidence for of that And here, the idea behind having high and sustained levels of stress physiology is you're then less flexible in your stress response, right? As I described before, the importance of being flexible in your stress response related to executive functions. And here are the children in the sample when they're 7 months of age and 15 months of age. And the dark bar are kids who are receiving really very sensitive care from their parents, from their primary caregiver, the sort of warm, sensitive interactions. And for other kids, not to point the finger or be accusatory, but because of the characteristics of the home they're in, their parents are less able to show that sensitive behavior. And what we see here is that in response to an emotion challenge, so what we're doing here is we're scaring little kids and frustrating little kids by showing them a series of masks or by giving them a nice toy to play with and taking it away and giving it back and taking it away and giving it back, that sort of thing. And what we see is when kids are experiencing this emotional response, those receiving the higher quality care are regulating their physiology in a way we would like to see or a way that we think is beneficial. The kids in the dashed line and the kids in the dark lines, they're no different in terms of their emotional response. They're both showing high levels of emotional reactivity, mainly to the mask task, to the scary masks. But their physiology is not working along with their behavior so much. And that's at 7 months, and then at 15 months, as you saw there, we're beginning to see that differentiation over time, and then we see that difference again there, right? So that levels are overall lower at 15 months and lower again at 24 months and lower again at 48 months, right? And the idea is it's not this flexible regulation that's going to set the table for the development of the executive functions. So, which gets to the really interesting stuff. In terms of executive function, what is it that we're assessing? What are we measuring? You may have heard of these skills, but they're actually quite simple that we're talking about. These are not sort of high-level, very difficult tasks. And so psychologists, enterprising psychologists have come up with some interesting ways of measuring executive function. And one is just this peg tapping task. When I tap 1 time, you tap 2 times, okay? And when I tap 2 times, you tap 1 time. Got it? And that very simple task requires just holding in mind the rule for responding and inhibiting an automatic response. It works like a charm for 4 or 5-year-olds. Like 3-year-olds have a lot of difficulty with it, doing it, and by 5.5 years, kids sort of really get the hang of it. But it works really well in that sort of sweet spot. So that's sort of the inhibitory control, working memory aspect of executive function. Here's a different one that's more like a shifting type task, sort of the flexible deployment of attention, to not put too fine a point on it. But the idea here is we just ask the child to show me 2 things that are alike on this page. Show me 2 things that go together. And generally, the kids point to the teapots. It's pretty salient. And then we say, great, good job. Now show me 2 things that go together, but in a new way. Show me 2 things on this page that go together in a different way. So the idea here is to shift from the dimension of shape to the dimension of size. Exactly. Those 2 things we're like, because they're both small. So we go through a lot of trials like this. This is what we're measuring when we're measuring kids' executive function abilities. They're not that complicated. So the problem with some of those tasks, though, is that they're really good for like 4.5-year-olds or 4-year-olds, but no 3-year-olds can do them, and all the 5, 6-year-olds, it's like too easy for them. So we developed some other sorts of tasks that are similar, like this one is just what color's in this house, what animal's in this house, what animal was in this house, or what color is this house. So just holding on to 2 pieces of information and responding to one, and then we can make it harder by having 2 houses or 3 houses or 4 houses, and then we can make it harder still by making the dog blue and the bird red. Believe it or not, when what's called the stimulus properties are bound together, it's a harder task to do. It's harder to inhibit one in favor of the other, that sort of thing. And then finally, sort of a tension-shifting task. The instruction here is to touch on the same side that the arrow is pointing to. And when the arrow and the response location are on the same side or congruent, it's a pretty easy task. 3-year-olds can do this. But when the arrow and the response location are incongruent, it's a little harder still. And then when we mix between the congruent and incongruent stimulus, it's harder still. So we have this battery of tasks that we're using to measure executive functions and the development of executive functions in young children, and it's freely available, and it's now on a touchscreen computer, so we get accuracy and reaction time as well. And what we've seen here is that, as expected, on the left-hand side of your screen are sort of the demographic characteristics, poverty, maternal education, and their relation to parenting. This is what's known as a structural model or structural equation model, and they predict the sort of parenting that children are getting. And through the positive aspect of parenting are associated with cortisol, with this aspect of stress physiology that I talked about. And then through that to executive functions, but not IQ, right? So IQ is a different thing, sort of general mental ability. We're talking about executive functions, which are what I just described in terms of what we measured. And so we are interested in this, or I've always been interested in this, because these self-regulation skills are so essential and so integral to what I think of as school readiness, right? That's exactly what is going on. When a child starts formal schooling, they're expected to be able to regulate their behavior. They're expected to regulate their attention and their emotion in particular ways. And if children have difficulty doing this when they start formal schooling, kindergarten, first grade, they're going to have a very hard time. That's just the way it is, because that expectation is there for the most part. And there's a reason why children start school around the age of 5, 6, 7 years of age, is because the idea is that prefrontal cortex, that area of the brain, has matured enough to allow for this intentional, volitional self-regulation of behavior. But of course, kids from disadvantaged circumstances are not going to show that behavior, right? They may be, by benefit of their early experience, they're less ready for school, but there are innovative ways of addressing these issues, right? So I won't go through this in the interest of time. This is my slide, one of my slides just demonstrating that executive functions are really important for early math. So the idea here is that it's not that self-regulation is the be-all and end-all. We really need to pay attention to basic knowledge, some certain skills. But when you ask kindergarten teachers what's most important for school readiness, they generally say self-regulation, right? Because a kid can come with all the knowledge in the world, but if they can't sit still and they can't pay attention, that teacher can't teach them. But a kid who maybe didn't come with the benefit of all of the earlier knowledge, if that child can regulate their behavior and pay attention, that teacher can teach them, right? So that's pretty straightforward. And the idea here is that the school readiness gap and the achievement gap that we see that's now so prevalent in our country, associated because we have such pronounced, seemingly intractable income inequality in our country, it doesn't seem to be going away. We know it's directly going to affect children's school readiness and experiences, which has huge implications for getting out of poverty, right? We're just setting up this self-justifying, perpetuating vicious cycle system with polarized income and opportunity in our society. Though there was a really interesting article on the front page of the New York Times yesterday about moving to opportunity, the extent to which the federal government has a lottery that allows families in high poverty neighborhoods to move out to higher income neighborhoods. And 20 years of the evaluation of that project have shown pronounced economic benefits for kids who get to move to opportunity. So there's some evidence of something that's working as well. So what can we do about it? So there are several that have approached this idea of self-regulation as a system. One is the Chicago School Readiness Project that was run by my colleague, Sibel Raver. She's now at NYU. She was at the University of Chicago before. And this was a program really to address high levels of behavior problems in kids. So these were kids showing up in Head Start classrooms with great difficulty regulating their behavior by providing teacher training, mental health consultation, and a program known as the Incredible Years. Behavior problems dramatically reduced in the sample, and the climate of the classroom improved immeasurably, right, as assessed by the classroom environment, the class measure, if you're familiar with that. And so the evaluation of this showed not only large effects on behavior in kids, but large effects on executive function abilities and the ability to control impulsivity. And through that showed effects on kids' academic learning. So it's a wonderful example of the extent to which focusing on emotion, which some people would say, why are you focusing on emotion? You should be focusing on school readiness skills, meaning teaching them letters and numbers and so. Focusing on emotion and changing the emotional climate of the classroom had big effects on kids' executive function, and through executive function on traditional indicators of school readiness, right? Another project, I was not involved in the Chicago School Readiness Project, was involved in this one, also in Head Start classrooms, Project Ready, and this combined a literacy approach known as dialogic reading, if you're familiar with that, with an emotion program known as the Promoting Alternative Thinking Skills Program, PAS. You may be familiar with PAS. PAS really focuses on emotional awareness, emotion identification, and emotion regulation. And again, in very disadvantaged Head Start classrooms, there were effects of this program on children's behavior and on their academic outcomes. This one was a little different in that the effects in Ready seemed to be among kids who had low executive function skills to begin with. Right, here's what's depicted in that. For kids with very low EF skills at the beginning, those in the intervention group did much, much better than their counterparts in the control group, right? So thinking about these interaction effects is what they're known as, right? So where would you want to see this effect? You'd want to see this work really well for kids with low executive function skills to begin with, right? When I said at the start of the talk, we really want to focus on the context of high disadvantage. And then finally, a program that my colleagues and I have been evaluating known as Tools of the Mind. I don't know if people are familiar with tools. Some of the research on tools has been positive, some of it has not been so positive, but that's why we do science. We recently completed 2 evaluations of Tools of the Mind, which is this, really focuses on self-regulation and really allows children to take direction in what they're doing. There's a lot of information about tools on the web. If you're interested in that, you can Google tools and find out quite a bit about it. Children, one of the main things is it's play-based and it's planning. So children are reflecting on their actions, they're explaining their actions, they're playing with peers, they are working one-on-one with teachers because a lot of it is play-based and the teacher has time to work individually with kids. One of the hallmarks of Tools of the Mind is it has kids do activities together. So here's a picture of kids doing an ordinality activity, and the child on your right is doing the activity, and the child on your left is checking the child's doing of that activity, right? So for mathematics, of course, you want to be able to do it, and you want to check your work, but you don't need to learn both those skills at the same time. The idea would be to learn them separately and then integrate them over time, and then the kids will switch roles, and the kid who's the doer will become the checker, and the kid who's the checker will become the doer, and it's all a lot of fun. And hopefully kids are learning a lot of math, or some math to begin with. So the other thing about tools is it's really what I'm talking to you today. If you like what you're hearing about what I'm saying in terms of self-regulation, that's what Tools of the Mind is trying to do to inculcate and talking to teachers about their goals for children and what they're doing. So there's a big professional development component to it. So we've evaluated, my collaborators and I have conducted 2 randomized controlled trials of Tools of the Mind. One was the pre-K version. There's also a kindergarten version, and the pre-K version was in Head Start classrooms and UPK classrooms in New York City with predominantly Spanish-speaking children. And what we found is that there were some main effects of this program in a randomized controlled trial on reading and math and English, and reading and not reading, but math and Spanish a little bit. Not huge, nothing to write home about in the sample overall, which contained some predominantly English-speaking children and some predominantly Spanish-speaking children. But when we looked at the kids who were identified by their mothers as really predominantly Spanish-speaking, that these kids speak Spanish at home, it's their main language, when we looked at the effects on those kids relative to their counterparts in the control group, who were predominantly Spanish-speaking, we saw big effects on these academic readiness indicators. We saw that particularly in math and English, right? So what was happening in the control group is that Spanish-speaking kids in control classrooms were not making much progress in their math and English, which is very important for going to kindergarten in New York City, relative to kids in the tools of the mind group. And we saw some similar sort of effects on reading, and then of course on math and Spanish and reading in Spanish also. So we were encouraged by this, and we saw some effects on executive function abilities too, that in the interest of time I won't go into it. So we're just writing these results up right now. We also evaluated the kindergarten version of the program. And the kindergarten version is just a more sophisticated version of the pre-K version. The play narrative is based on the Magic Treehouse books, so kids here are doing whichever Magic Treehouse book is about pirates. And they build the sets, they reenact the chapters that they've just been read to by the teachers, and that's a large part of the play aspect of the kindergarten version. Children then plan their center-based activity and actually have a meeting with the teacher to talk about the progress they're making in the different centers, their goals for the future in those centers, reflecting on their prior experience and connecting it with their future experience, which is a sort of classic definition of executive function. We did the same cluster randomized controlled trial of the tools of the mind. This was in Massachusetts. We had variation in free and reduced lunch here. And what we saw, again, modest effects in the sample overall. But what we saw were large effects on executive function, on working memory, on speed of processing, the ability to control attention and not be distracted by emotion, which is this thing called the dot probe, a little bit on math and reading, but really big effects on reasoning and vocabulary in kids who are in high poverty schools, so free and reduced lunch greater than 75%, right? And the really interesting thing about this is that though we saw modest effects on reading at the end of kindergarten, we saw effects on growth in reading into the first grade. So very, very impressive. I've almost never seen programs have effects on growth in reading into the first grade, which suggests that it's working the way that it should. And also growth in vocabulary. So here, the difference at the end of kindergarten, the gray bars are the control group, the dark bars are the treatment group, growth in vocabulary into the first grade. So the idea here is that this is a good foundation for later learning. And then we did see effects on classroom quality just very quickly here. The idea is that in the high poverty schools, the tools of the mind classrooms look very good. They look no different from a low poverty school classroom, whether treatment or control, but the control schools are showing that expected relation between percent free and reduced lunch in classroom organization. So with that, I'm going to have to stop here. There are some conclusions and implications, but I'm really out of time. I think one of the things that I want to just finish up with really quickly is I've been talking a lot about stress and the harmful effects of stress. The idea is not that all stress is harmful. It's controllable stress. And I think that's what resilience is, the ability to recognize, handle, control stress, and that moderate amounts of stress and the ability to work with stress are really key to supporting self-regulation. And here my collaborators on this research at Penn State University, University of North Carolina, Chapel Hill, New York University, the Tools of the Mind folks, and our funders from the NIH and from the Institute of Education Sciences. And I run an active lab, Neuroscience and Education Lab. We're always looking for partners, especially in North Carolina right now. We're running a measurement of pre-K study. If you like what you see or you like what you heard, please visit our website. Please send me an email and get in touch. And let us come collect SPIT data and executive function data from kids in your classrooms. So with that, I got to stop, and thank you very much.